Assalamu alaikum wa rahmatullah. For this session, we will discuss the function, one of the function of the kidney, which is the maintenance of acid-base balance. About the acid-base balance, you know from the previous sessions that the blood pH is range between 7.35 to 7.45. And it has to be maintained in this range, because if it is going below the 7.35, it will be considered as acidosis. So, and if it is going up more than 7.45, it is become as alkalosis. So one of the function of the kidney is to maintain the acid-base balance by increasing the filtration and excretion of hydrogen ions from the body. About the process of, or the pH, as we said, if the pH it is considered as neutral, or when it is between 7.35 to 7.45 in the blood. If the hydrogen increased, in this case, it will be going to acidosis. If the OH increase or hydroxide is increased, it will be going toward the alkalosis. So the pH of blood, again, it is from 7.35 to 7.45. If it is going up toward OH, in this case, because the pH is from 0 to 14, if it is going more than 7.45, it is going toward acidosis. If it is going less than 7.35, it is going toward acidosis. So, which is a physiological acidosis and physiological alkalosis. So, the acid-base balance, most ions originate as a production of cellular metabolism. So it is mostly produced by the metabolism of inside our body. A small amount it will come in the diet. So the acid-base balance, most acid-base balance is maintained by the kidney, as we said. Other acid-base balance controlling system, there are two systems which control the acid-base balance. One of them, which is the buffer, blood buffers, and the other, which is the respiratory system. The buffers, if we have a strong acid like HCl, when it is dissociated in the solution, or it will be hydrogen and chloride. So all of it will be dissociate as hydrogen positive and chloride negative. So, which is a strong acid, it will dissociate as hydrochloric acid, and the pH, in this case, it will go down, so the acidosis will be there. In the buffer, if we are having weak acid, it is partially dissociated, like the carbonic acid. It is only, it is H2CO3, so it has two hydrogen ion. One of the hydrogen ion, it will dissociate here, so it is a weak acid. So not all the hydrogen will be as an ion, as a free ion in the blood. So it will be considered as a weak acid. But here, the hydrochloric acid all will be dissociated in the solution in the blood, and it is a strong acid. So the buffer work by binding hydrogen ion to make them a weak acid. So it will bind the hydrogen ion to make them as a weak acid. So the number of hydrogen in the blood, it will be less. By that, it will maintain the pH of the blood, or to release them again depending on the hemostasis needed. So if the pH is going toward acidosis, in this case the hydrogen ion, it will be taken and to bicarbonate, and by that it will decrease the number of free hydrogen ion in the blood, and by that it will decrease the acidosis. If it is going toward alkalosis, then there will be dissociation of more acid and changing them in as a strong acid. So the blood buffer molecules react to prevent the dramatic change in hydrogen and increase or acidosis. Concentration, it bind to hydrogen when the pH drop, so, and release hydrogen when the pH raised. So when the pH raised, it will release hydrogen, and it will bind hydrogen when the pH is dropped toward acidosis. The major chemical buffer system in our body, there is the bicarbonate buffer system, the phosphate buffer system, and the protein buffer system is there. So there are three: bicarbonate and phosphate buffers and protein buffer system. The bicarbonate buffers, it is a mixture of carbonic acid, H2CO3, and sodium bicarbonate, NaHCO3. So it is mixture of carbonic acid, the H2CO3, and sodium bicarbonate, NaHCO3. So the bicarbonate ion, HCO3, react with a strong acid to change them to weak acid. So they will react with a strong acid and take one hydrogen ions in order to make them as a weak acid. So the HCl, which is a strong acid, plus the sodium bicarbonate, which is a weak base, the buffer solution, it will take hydrogen from both, so it will give H2CO3, which is a weak acid, which is the carbonic acid, so strong acid, plus weak base buffer, it will give a weak acid plus carbonic acid, weak acid, which is the carbonic acid, plus the sodium chloride. It will give sodium chloride. So strong acid plus weak base, which is the sodium bicarbonate, the HCl plus the sodium bicarbonate, it will give a weak acid and sodium chloride. By that, it will neutralize the blood. The bicarbonate buffers also, it is strong base is present. If strong base is present, the carbonic acid, it will dissociate from weak base and water. So the NaOH, which is a strong base, when it is dissociated, it will be dissociated to sodium and OH. So strong base, sodium hydroxide, plus H2CO3, which is a weak acid, which is as a buffer, which is the carbonic acid. It will give the sodium and HCO3, so it will give a weak acid, which is sodium bicarbonate, plus the H2O, which is water. So strong base and weak acid, it will give weak acid and water. So it will give weak acid and water. So by that, it will maintain the pH. About respiratory system and acid-base balance, the carbon dioxide in the blood, it is converted to bicarbonate ion and transported in the plasma. So it is as a bicarbonate ions. Increase in hydrogen ion concentration produce more carbonic acid. So when there is increase in hydrogen ion concentration, it produces more carbonic acid. Excess hydrogen ion can be blown off with the release of carbon dioxide from the lung. So it will go out from the alveoli and expelled out with the expired air. Respiratory rate can rise and fall depending on the change in the blood pH. So the blood pH also, it will affect the respiratory rate and depth. So the CO2 transport and loading in the tissue, so CO2, it will be coming out from the tissue to the blood vessels, it will be loaded in the plasma. So most CO2 is transported in plasma as bicarbonate ion, as we mentioned before in respiratory system, as HCO3. CO2 also combined with water to form carbonic acid, which is quickly dissociate, forming bicarbonate and HCO3. So CO2 plus water, it will give H2CO3, which is carbonic acid, and then it will give hydrogen and bicarbonate ions in the body. Then the unloading that it was in the tissue, now unloading in the alveoli. In the alveoli, the unloading of CO2 here to alveolar sac. So CO2 transported, unloaded in the lung. The HCO3, which is the bicarbonate ions, plus hydrogen, it will give carbonic acid. Then it will give CO2 and water. So it will dissociate to, so it will be changed to, it will give us carbon dioxide and water. So bicarbonate ions and carbonic acid, which is the acid and base here, or sorry, here, yeah. So it will give CO2 and water. So the CO2, it will be unloaded, sorry, to the alveoli, and it will be going with respiratory. So this is in the pulmonary capillaries. From the pulmonary capillary, the HCO3 minus and hydrogen, it will give HCO3, H2CO3, and it will be changed to CO2 and water, H2O. So the H2O, it will remain in the blood, and the CO2, it will be unloaded to the alveoli, and it will be going with the expiration. The respiratory system acid-base balance, so hydrogen released is forming a bicarbonate in the tissues, and the hydrogen ties up as water when CO2 is unloaded in the lung. So it will give water and the carbon dioxide, it will be unloaded. Thus, normally, the hydrogen ions produced by CO2 transport have no effect on the blood pH in this case. Why? Because it will be excreted from the lung, unless if there is any other condition. But when hydrogen ion increased by any reason, example in case of respiratory disease, in this case more CO2, or by metabolism, so more by metabolism, in metabolism it will produce more hydrogen, so the respiratory center is stimulated, so it will increase respiratory rate and depth. It will increase the respiratory rate and depth in order to blow more oxygen outside. So to blow more carbon dioxide outside of our body, to get rid of the carbon dioxide which is present in our blood, which is cause acidosis. So reverse will happen in alkalosis. In case of alkalosis, when the pH is more than 7.45, so that's to say respiratory center, it will be depressed and retain the CO2, and it will lead to that hydrogen, it will be released out. In renal control, the buffer temporarily will tie up the excess acid and base, but eliminating them is the job of the kidney, which is except for the CO2 removal, which will be removed by the lung. But the other, which is mainly by the metabolism, and the hydrogen ion, it will be removed by the kidney. But the CO2 only is removed by the respiratory system. So as the pH raise, it means that it is more than 7.45, which means alkalosis. Bicarbonate ion are excreted from the kidney, and the hydrogen, it will be retained. So it will be prevented, it will be reabsorbed, and by that it will maintain the acid-base balance. If the pH fall down, if acidosis, if the pH is less than 7.35, in this case, bicarbonate is reabsorbed in order to maintain or to raise the pH of the blood, and the hydrogen, it will be excreted and it will not be reabsorbed. So by that, the pH, it will be maintained. So slower than buffer, that's to say it takes hours to work in order to do that. Urine pH varies from 4.5 to 8 according to the metabolism and according to the pH of the blood. So either it will be it will be acidic in case if the hydrogen ions are more in the blood, so it will be acidic because the kidney will excrete more hydrogen. If the buffer, if the blood is or the bicarbonate is more in the blood in this case, it will be going toward alkalosis or alkalinity. Thank you.